Hello viewers, I'm your instructor Zaid Ali and you are watching the channel ZQTech. Today the topic of the discussion is docking. Docking is necessary step to keep the ship moving in ocean. So let's briefly start the description of this topic. First move forward to the definition of docking. The method required for the regular maintenance and repair of the ship in such a way that the ship is taken out of water and then keep it upright with the help of blocks which are under keel. These blocks are specially designed to hold the ship's fate. So this method is known as docking or grounding the ship. Conditions for docking. So the following conditions must be met before doing the docking. Ship is stable and GM is positive. I know that you people know about the GM. GM is basically the metacentric height and it is important criteria for the stability of ship. Without stability, we cannot dock the ship. Dock length, beam, draft are enough greater to contain the ship. Ship trimmed slightly by stern before docking. All tanks are empty except the ballast tanks and ship is unloaded. Ballast tanks are such tanks which are used for the stability of ship. So in the ship, the ballast tank contains the water. Blocks are adjusted carefully on the dry dock. Powerful tug-pull boats must be available. So these powerful boats push the ship into the dock platform. Now we discuss the docking general process. This docking general process is same for the dry docking. So let's start with the first step. Sending docking plan and stability conditions to the dock master. So the designer sent the docking plan and the stability condition criteria to the dock master, and dock master studied those things and made his own docking plan according to these criteria given by the designer. Arrival. Ship arrives outside the dock with the minimum ballast water. Meeting. A final meeting is done between the dockmaster and the officers for the final decision of docking the ship. Adjusting ballast. Ship is made to trim by stern slightly when it is out of dock. Bring to dock. The powerful boats, which are the tug-pull boats, pushes the ship into the water-filled dock. Let's move forward. Inspection. Dockmaster and diver check the ship alignment with the block. Diver goes down into the depth of dock and check the alignment of blocks with the ship and gives signal to the dockmaster. So hence both are simultaneously adjust the alignment of ship with the blocks. Dock water removal. Caissons closes the dock and pumping out water from the dock. So caissons are basically a concrete gate which is used as gate for the dock. So they are basically closes the gate of dock and then the process of pumping out water from the dock occurs. Dock empty. When the dock is out of water or dock becomes empty, then the ship sits on the block all the way. Now the ship whole weight is beared by the blocks. After this, shore power. Shore power is supplied to run the ballast pump. In the ship, we need to empty the ballast tanks. So there is need to run the ballast pumps. So that's why shore's power supply is supplied from outside of ship alongside of the dock platform. Deballasting. Pump out all remaining ballast on the dock master instruction so that there is no fluid in the ship. So that is the general process of docking or dry docking. Ship is completely dry docked, so don't wait. Go down the dock and look at the ship hull. You come to know that ship really needs maintenance or repair. So here is the picture of the ship and two important points you must know before moving forward. Cut-up. Cut-up is basically such portion of ship in which there is no hull is present or there is no material of hull is present. Basically this cut-up material contains the propeller, rudder, and there is no buoyancy force acting there because that portion is not a part of the ship that is immersed in the water. And after cut-up point, this is basically a point from which the hull starts or the point at which the cut-up ends. So remember both the points. Theoretical understanding. So before moving forward to the brief concept of docking, you must understand the theoretical concept of docking. So here is the critical point, and that is the thrust force T is acting upward, and these are the blue arrows are the buoyancy arrows. Buoyancy is acting upward while the weight of the ship is acting downward. So move towards the definition. Critical point. When the stern of the ship start touching the first block, then this point is the critical point, and at this point the block starts acting an equal and opposite thrust force on the ship. So in this case the equation will be weight of the ship is equal to buoyancy force plus the thrust force, and GM starts loose virtually at this point. So that line is very important. What is the meaning of this line? The GM starts loose virtually at this point. Actually, the meaning of this line is that when we are docking the ship, we want in the docking condition that the ship does not show heeling, does not show pitching when it is completely sits on the block. And we don't want our ship when it is completely sits on the block so that it heels or pitch or any other motion. It will not shows its movement like the pendulum. So that's why when it does not shows like the movement of pendulum, then the GM is virtually lost. Hope you understand this point. So now discuss the points. Critical instant, the point at which the bow of the ship touches the block and now its weight is completely supported by the blocks, is the critical instant. So in the picture you can see the critical instant point. Now move towards the definition of critical period. The time from when the stern touches the block to when full ship is on the block is the critical period as shown in the picture. So in this condition the weight of the ship will be equal to the thrust force. So now we can say that the GM is virtually lost totally. As I have told you before that when the ship sits on the block, then the GM lost virtually. So I hope that you understand the concept of GM is virtually lost, because the GM is basically the metacentric height and it only works when the ship is heeling or when the ship is pitching. And I suppose that you know both the phenomena of pitching and heeling of the ship. If you didn't know these phenomena, then search on the internet and you will find out and you will clear the concept of GM is virtually lost. So move forward, and formula for the thrust force is T is equal to MCTC multiplied by trim divided by length. MCTC is given by the designer while trim of the ship during its critical period. So during its critical period, ship is in the trim. So when the ship completely sits on the block, then there is no trim. Length is basically the distance from the block to the center of flotation. Virtual loss of GM. There are two formulas, but you can use any of these formulas to get the GM lost. Both formulas will give the same answer. So the first formula is GM is equal to T multiplied by Km, the distance from keel to the metacenter, divided by weight of the ship. And the second formula is GM is equal to T star kg. Kg is distance from keel to the center of gravity divided by W minus T. And again I am telling you that T is the thrust force acting by the blocks upward on the ship. Types of docking. So first type is dry dock, second type is floating dock, third type is ship lift and transfer system docking. So first discuss about the dry or the graving dock. Here its definition. These docks are large hole in the ground, lines with a masonry or bricks, and entrance gates in the form of caissons or hinge gates are present. In such method, the ship is allowed to ground onto the fixed dock floor without damage under the gravity. So previous in the video, I have told you the general process of docking, and that docking process was actually for the dry docking. So here in this page, I will discuss some important points of the dry docking. You must study these points and try to understand those points. Docking plan is made for each ship separately. So discuss the first point. The first point is some blocks may also be removed in the way of projections below the keel line, like the propeller blades can run below the keel line and echo sounder. So first point basically means that the block must be removed under the ship from those points which are projecting below the keel. And the second point is breached shores. Breached shores are basically the handles and hold the ship against the tripping, are adjusted outside the hull at the location of transverse bulkhead so that they could better able to get the forces. And again, I am telling you that the transverse bulkheads are present inside the hull, while breached shore will be present on that location of the transverse bulkhead outside of the hull. Alignment of the block must be checked carefully before dock flooded. That is the third point. Now the fourth point. Center line of the ship must be in line with the block before deflooding. And the fifth point, when after cutup touches the block, a thrust force begin to develop at the cutup. Docking method in which the placing of an elastic ship of an uneven weight distribution onto an elastic sets of blocks, which in turn supported by the elastic floating dock. Hope you understand the definition of this floating dock. Here, elastic means that it is little or temporarily bearing the stresses as a result of force. It doesn't mean that it will or any material will stretch like a rubber or expand like a rubber. So elastic here is meaning that when load is applied on the blocks by the ship, then as a result of this load, the temporarily stresses will induce in the ship as well as in the block. So when the load is removed, when the ship is removed, then these stresses will be vanished. Here you can see the side walls and pontoon of the floating dock, and that is the general picture of the floating dock. If you see at the right picture, you can see the blue blocks are the ballast tanks filled with the water, and when we move from the left to right, then you can see that the floating dock is moving upward, and at the end picture it holds the ship completely. Here are some important points of the floating dock. So let's start. U-shaped block. Usually side walls are mounted on the pontoon base. Its large part is based on the ballast tanks. When they are filled in, sinks the dock because to move the ship to the correct position. Tanks pumped out water. Then the dock with the ship rise up. Transverse and longitudinal stability is very high when operating freeboard. Operating freeboard means above the water level. They are used when shipyard have no dry dock facility. Lifting capacity. Lifting capacity depends on the buoyancy available to hold the dock when working freeboard. When working freeboard meaning that it is holding the ship out of water. So at that time, how much buoyancy is acted upon by the water from the below side. Floating dock can heel or trim as like of ship to match the damaged ship condition. Usually the lifting capacity is between 400 to 1 lakh tons of the floating dock. In the floating dock, block will support the ship weight, so W block is equal to ship weight, as you can see in the picture. Moreover, the weight of the dock plus weight of the ship is balanced by the buoyancy force of the water. So F buoyancy is equal to W ship plus weight of the dock. Buoyancy force is acting upward while ship and the block weight are acting downward. If you see on the picture that in the midship section, the weight of the ship is more, so the large buoyancy force will need to support that midship section. So as you can see in the graph that the middle of the graph is quite high values. So these are the buoyancy values as a result of ship weight. So here is the general picture of the floating dock. SLTS, Ship Lift and Transfer System. Ship lift and transfer system are the devices providing the means of lifting the ships vertically out of water to a level where they can be worked on. Lifting capacity means that maximum load distributed per meter. Elements of ship lift: articulated steel platform with a wooden deck, rail-mounted system, and block are attached on the deck. So here you can see wide rope hoist along each side of the platform for lifting the platform, attached with the load measuring devices to check for the load distribution. So here in the blue shape along the both sides of the platform, these are the wide rope hoists. These contains wires in them. A cradle is configured to suit the ship hull form. You are thinking about what is cradle and what are the wide rope hoists. So let's see. This is the wide rope hoist. It contains the motor wires which are used to lift up the platform of the SLTS. While what is cradle? Cradle is basically attached with the blocks. The blue shapes are the blocks, while the black shape are supporting the hulls. These are the cradles. Cradles are basically used to support the ship hull so that it cannot heel or pitch. To discuss the importance of this system, SLTS, Ship Lift and Transfer System. Docking, launching, assembling the ship blocks. Reduce the crane usage. Safe, reliable and economical process. Transfers and longitudinal motions. Its mean is that it can make the ship to move along its length and also make the ship to move along its transverse section. In other words, it has ability to make the ship move along its x-axis and also ability to move the ship along its z-axis and also ability to move the ship along its y-axis. So when it will make the ship to move along its z-axis when it is lifting, this system is lifting the ship, then it is moving the ship in the z-axis, and when it is transferring the ship from the platform to the berth, then it will make the ship to move along the longitudinal axis as well as the transverse axis. Here, the weight of ship from 1000 to 30,000 tons. Here are some pictures of SLTS. In the left picture, you can see the blocks with the rails, and in the right picture, you can see the overall SLTS system. As a naval architect, you must remember some things for the docking. A huge responsibility for calculating the stresses on the dock as well as on the ship structure. Monitoring the load distribution during the ship lifting in case of SLTS and floating docks. Main features to concern in the docking for a naval architect are load distribution between the ship and block, behavior of the block, strength of the floating docks, stability of the ship in all the three cases. Hope you understand the concept of docking. If you didn't understand the concept of docking yet fully, then do read these books. Any queries, comment below. I will sort it out. Thanks for watching.